All right, hello everyone. My name's Lauren Ruelas, and I'm going to be teaching you guys about Dilantin. I want to start off by saying that I did not know that you had to record yourself drawing the images, so I am redrawing them in the video, not as high of a quality, but you can see in the pictures above that they look much nicer, much prettier. So Dilantin is an anti-seizure medication that is used to prevent grand mal seizures and focal seizures. The drug can be taken orally or intravenously, which is through your veins. It can have side effects like nausea, stomach pain, loss of appetite, poor coordination, increased hair growth, and enlarged gums. There's also sleepiness, self-harm, liver problems, bone marrow suppression, low blood pressure, and toxic epidermal necrolysis. Lots and lots of side effects that are possible. Dilantin should not be taken if you are pregnant or if you drink frequently. The reason you should not take it when you are pregnant is because it can cause abnormalities to the fetus. It was also shown that if you take antacids with Dilantin, it can cause the medication to not be absorbed properly by the body. And also, Dilantin causes birth control to be less effective, which I thought was pretty interesting. And something else interesting that I found was that a small-scale study was conducted, and it showed that Russian inmates took Dilantin to help reduce anxiety and negative thoughts, which is kind of interesting because before in the side effects it says that it increases negative thoughts. I also forgot to mention that the generic name of Dilantin is phenytoin, and the chemical name is 5,5-diphenylidantoin. Very long name. Excuse my pronunciation. The chemical formula is C15H12N2O2. And that is pretty much it. So thank you guys for bearing with me, and enjoy the next half of the video where I will be finishing up the drawings. All right, thank you guys. Hello everyone and welcome back. I will be talking about the rest of the molecular portfolio with you. When we last talked, I believe we went over pages 2 through 5. I showed you the structure of the formula. I talked a little bit about what the drug does and how it helps seizures and everything. Now we're continuing on page 6. So on this page, it asks to go over the molar mass and the molecular formula. In the last video, I did say that the molecular formula was C15H12N2O2. If you calculate the the molar mass for each of these elements, they come out to this, and then when you add them all together, it's 252.27 grams over moles, and that's the molar mass of the entire molecule. So continuing on with page 7, it will ask to go over hydrogen bonding with this molecule. It will talk about how it wants you to find where water will bond with this molecule using hydrogen bonds, and these are all the places that I found should have a hydrogen bond. All right, moving on, then it'll ask you to find hydrogen bonds for your drug in water. And I found that right here there should be a bond, right here, and you can see the rest. So yeah. Okay, so on page 9, it talks about polarity and solubility, and asks you to go over all the polar portions in your drug and if your drug should be soluble in water. So let's just go back to the molecule. So going back to the molecule, you can see that the line bond structure looks very symmetrical. On both ends, there's these carbon rings on both of these ends, and then the oxygens and the nitrogen-hydrogen bond. It looks very, very symmetrical. Now going on to the expanded formula, again, very symmetrical. I mean, it's the same molecule, but very symmetrical. The only really big electronegativity difference is right here between nitrogen and hydrogen. And there is the carbon and hydrogens, but again, they're all symmetrical in a ring. So it's not a very polar molecule. It's pretty non-polar. So in my opinion, I do not believe that it will be soluble in water. There's not a lot of likes with it. Water is very polar. It's a very polar molecule, and having a non-polar molecule mixed in with that, it just wouldn't really work like oil and water, basically. I did look it up, and I did find that I was correct. It's not it's not soluble in water. It is soluble in acetone, ethanol, and alkali hydroxides, but not soluble in water. So let's go back to, I believe, the last page. Okay, so going back to the last page, this is solution calculations. In the first question, it asks you to prepare 50 milliliters of your solution with a molarity of I believe it's 0.023. So yeah, so I did all calculations. If you turn 50 milliliters to 0.05 liters, and then you multiply that by the molarity, it equals 0.00115 moles. Now you take that moles and you multiply it by the molar mass that we found earlier in the molecular portfolio, and you get 0.290 grams. So to prepare the solution with the molarity that I asked, you just want to mix 0.290 grams of the drug into 50 milliliters of deionized water, even though we just found out that's insoluble in water. Okay, for the second question, it wants you to find how many milligrams of the drug are contained in 2 milliliters of a 3.0% solution of the drug. So if you take 3.0% and you divide it by 100 to get a decimal amount, you get 0.03 grams over 1 milliliter. And then if you do proportioning and equal that to an X amount of grams over 2.0 milliliters of the drug, you'll just have to do this to find that it'll be 0.06 grams is that missing amount. And then if you multiply that by 10 to the third, it'll equal 60 milligrams. So that's how many milligrams of the drug are contained in 2.0 milliliters of the solution. Anyway, thank you guys very much for listening and for completing this molecular portfolio with me. Again, my name's Lauren Ruelas, and I hope you enjoyed the video.